Hi, my name is Masood. Welcome to METE3100 lab. This video is introduction to the motor control unit which is used in the lab by the students. This is the top view of the unit. This unit has been completely designed and manufactured in Faculty of Engineering at UOIT. You can see the top view here. The actuator part includes 5 different motors. The first one is a DC geared brushed motor. It's a 4:1 gear ratio. The next one is a brushless motor. It's a DC brushless motor. Next one is a unipolar stepper motor, and then we have the servo motor on the side here. We have a printer slider that has a stepper motor that controls the movement of the slider. So on this unit we use it to control the stepper motor. As a result, we can see that the slider moves back and forth, and all these motors are controlled by an Arduino Mega which is on board. The unit provides a USB connection to the laptop, and this is where the power connections are. There are 12 volts and 5 volts connection. Different motors on this unit use different voltages, either 5 or 12 volts. And then you can see also a current sensor, an onboard current sensor, which is designed to measure the currents for different motors. The rest is the connections. So all those banana plugs on the board, they are providing the connections for the test point. I forgot to mention about the LR circuit which is installed inside the unit. There is a high wattage resistor, value of 25 ohm, and this big inductance is providing 2 separate inductances, each value of 240 microhenry, and this is used to for the part of the lab, lab 1 specifically, to apply the PWM signal to the circuit and then measure the output. For the boards that you can see inside, we have 6 power MOSFET units, 4 of them. The one on the right side, they are used for to power the stepper motor, the unipolar stepper motor. And then the 5th one, which is second, like from the left, this one is used for the DC brush motor, to control the DC brush motor. And the very last one is providing the power for the LR circuit. We have an H bridge. So this is the H bridge board, and the H bridge is used to provide the power for the printer slider. So the stepper motor on the printer slider is controlled through the H bridge. Besides each unit, you can see the test points or the outputs, or maybe even inputs. For example, here you can see the speed controller outputs, number 1, 2, and 3, and it says ESCN signal. That's the signal which is commanding the speed controller that controls the speed of the brushless DC motor. Or here you can see the plugs for the current sensor. So if you want to measure any current, that current has to go through this plus and minus plugs for the current sensor. Or here you can see the servo signal. So the servo signal that is commanding the servo is monitored here. So I'm going to run the DC motor. So you need, of course, an Arduino program. So the Arduino program is written here. It's already compiled into the unit. All I have to do is just to power the unit to the 5 volt, because our DC motor, the brush DC motor, is running off of 5 volt. I'm going to turn it on. and then you can see that the motor started to rotate. You can see that there is a counterweight connected to the shaft of the motor, which is going to be used for DC motor experiments. And then if you want, these are the encoders, the output of the encoders. There is a 2-channel encoder which is integrated into the DC motor unit, channel A and channel B, and these are the signals. I'm going to use an oscilloscope, so the channel is connected here. Make sure that one of the cables is connected to the ground, and I'm going to fix it here. And then if I click on auto scale, I'll see the pulses for channel A. You can connect the same way for channel B and then monitor the encoder signal on channel B. So before coming to the lab, what we need from you is a wiring diagram that shows the connection for any of the components that you need for that specific lab. So what we have done, we have sort of converted this whole board, the block diagram. We created a block diagram here on Appendix B. So Appendix B, you see all the modules from printer slider on the top, then servo motor, LR circuit, and you can see also the 6 power MOSFET units. So all the units that you already saw on the board are here. For each board, the number of connections that we need are defined by the number of lines that are coming out of the block. For example, the LR circuit has 6 connections, so that's why you see the 6 lines coming out of it. So if you are doing the lab that needs the LR circuit, then you have to show us how you use the power MOSFET and the LR circuit along with the Arduino board to power the LR circuit. You need to also refer to Appendix A, which includes all the data sheet for the electronic components that we use. For example, on this page you have the Gravity MOSFET power controller. You can see that the Gravity MOSFET power controller has 6 connection, 1, 2, 3, and there are 3 connections connected to this header. So there are a total of 6 connections that you have to find out. We have given you, for example, in the lower pages, we have given you an example of the connection, so that could give you an idea. And there is also a sample code that for some of the components that you might be able to use. So all these connections, you can show it. It's in JPEG format, so you can open it up in the Paint and just connect the lines together and show us a soft copy, and then you have to print it and attach it to your lab report when it's finalized. And then when you come to the lab, based on the lab manual, you have to do the connections, and all the connections are done through the banana to banana cables. So make sure you do the right connection specifically for the power circuit, because if the power is wrong, then there is a chance that the component is going to be burned out. So this was an introduction to the motor control unit for the METE3100 lab at the Faculty of Engineering at UIT. Thank you.